A phase transition is when you make some change in a system that causes it to go from one state to another. It's made of the same stuff, it just behaves differently.
So the obvious thing everyone's familiar with is boiling a pot of water. And what happens is inside the water, you'll get little bubbles where the water is heated up and undergone a phase transition is now a gas. And then you'll see, in the case of water, the bubbles will bubble up and the gas eventually goes into the air.
It's such a common thing that exists. It's not unthinkable to believe that it happens at some point in the history of our universe. Why do you think the early universe? Well, because we have a really good reason to believe that it was much, much hotter then.
It may have been that as the universe was evolving and it was cooling down and its temperature was dropping, it may have undergone various phase transitions. And in those, you can get lots of interesting things happening. So you can have bubbles forming, for example, and then they will expand and eventually they run into each other. When this happens, you can produce gravitational waves.
We don't get to take a picture of the entire universe and watch it evolve and do this many, many, many times and repeat experiments and change parameters like you would normally want to do. But it turns out you can do this with these really fascinating quantum systems that people can build in the laboratory. And there's an amazing analogy between the way that these systems behave and the way that these fields in the early universe behave. So if I look at this field and I look at little waves traveling around in this field, the properties of these waves I can show mathematically are exactly the same as the properties of the waves in these little systems made out of atoms in the laboratory, which is mind-boggling.
What I'm hoping these analog systems will do is sort of, okay, it would be a bit boring to be like, yes, all the things you're doing in the universe, yeah, we've confirmed that that is the right intuition that you have. A really terrific thing would be like, no, here's something totally new that was unexpected. That's hoping for too much, of course. But I think it's really giving us a little bit more confidence that our intuition for how we think about cosmology really is the right intuition.
I would love to see these experiments come to be and test my predictions. My simulations rely heavily on all of these approximations. I would like to see that these common patterns in the manipulation of bubbles actually happen in nature.
I'm most excited to see one of these bubbles in the lab. I think that would be a really exciting moment. But I think that the even more exciting thing going on from there is getting some answers to these questions. And in particular, what if we're completely wrong? Because it's a really difficult question to answer. And yeah, there's loads of things that we could learn from the answers we get.